So when people are coming, let me remember you that we are organizing the third Congress, World Congress on Logic and Religion at the beginning of November in India, from November 4 to 8. So everything is on the way. So everybody is welcome to join us in India, Varanasi, nice town. It will be a really in-person event. So we will have no online talks. And the situation right now in India is quite good to travel. We will put more information on the website about practical information, how to go to India and so on for people who have never been there. So today we have one more session of the Logic and Religion webinar. And we have today as a speaker, Stanisław Krajewski from the University of Warsaw, was one of the main organizers of the previous edition of the World Congress on Logic and Religion in Warsaw. And as chair, we have Sadegh from Iran. So we is also a member of the scientific board of Logic and Religion Association. So please, Adi, you can go ahead.
Thank you very much, and welcome everybody. And let me introduce our today's speaker to you so that we can start the talk. Well, it's my pleasure to introduce Professor Stanisław Krajewski from Warsaw University. He has a broad set of research interests ranging from logic and philosophy of mathematics to Jewish and interfaith studies. He is also a lifelong active member and leader of the Polish Jewish community and co-chairman of the Council of Christians and Jews. Today, he is going to talk about a very interesting interdisciplinary titled Mathematical Models in Theology. So without further ado, I invite him to start the talk. Please.
Thank you very much. Thank you for the introduction. It's a very nice occasion to speak to people interested in such matters. We can also, of course, ask the question, in what sense mathematical models in theology relate to logic and religion, but I think it's pretty obvious that mathematical models are sort of very, the well-developed logical models, I would say, at least one variety of the possible models that can be called logical. And of course, religion is our interest. So, and theology is connected to religion in a well-known way. I will be sharing my screen, so let me do it. Just a moment. I hope you can see it. Yes, good. So the question is, how useful are such, do they exist, first of all, and then how useful they are. Let me begin by saying that, models, mathematical or other models, are really metaphors. And I think it's important to realize that metaphors are indispensable in our thinking in general. Our language depends on them. It has been emphasized by various scholars, especially Lakoff, in his well-known book, Lakoff and Johnson. But anyway, this is something that you can either agree with or not. But as I said, mathematical models can be seen as metaphors developed in a very strict and precise way. So I would say that they are, can be seen as a result of the use of logic for constructing elaborate metaphors that can help in theology, if they can do. So this is the question, how helpful they are. We can ask because, there are some examples. I will be giving you some examples, but the question is if they really help us to understand religious matters or theological problems, and in what sense. And a more serious question, and even I would say, certainly more difficult one is, can such models, mathematical models of theological divine matters, be helpful and suggest new insights, theological or religious? And this is, of course, the most difficult question we can ask. And I will be giving a survey of various attempts from, old times until recent times, but in a critical mood. I think we should be critical, not because I'm against mathematical models in theology. I am very much in favor, but I think that we should be very careful and critical, and whether they are really good, it should be shown, and we should very critically look at all those attempts, because otherwise everything remains in the realm of naive thinking, I would say. Okay, so to begin, let me mention only that I'll be using two publications of me, one which was in the Journal of Applied Logics. It's edited together with Ricardo, and this is and the recent one, which is more general, not just models but more general things, connecting religion to mathematics in both ways. And this has appeared so far only in this Sri Raman edited huge handbook of the history and philosophy of mathematical practice. It's not printed yet, it's only available online from Springer. Okay, so let's begin by some historical examples. The first to mention is Nicholas of Cusa, who in the 15th century, he used really various mathematical considerations as part of his theological thinking and writings. And to him, mathematics and theology are parts of the same domain. This is very far from what we are thinking in our times about those two sciences or those two fields of scholarship, but to him it was clear that they do belong to the same sort of domain. He wrote that since the pathway for approaching divine matters is open to us only through symbols, make quite suitable use of mathematical science because of their incorruptible certainty. So yes, mathematical models are the best models for theological matters. He was, he seems to have thought. So for example, he gave, and for him it was the sort of via negativa to God, that is because God, involves, various inconsistencies and infinities and such things. And so we can only try to understand them by looking at models that are finite, of course, but somehow, useful. And one of the simplest models he was using was circles tangent to a given line in the same point. You have circles that are larger and larger and larger, and he says that thus they we would say they tend to be so large that that there would be in really the same as the line, but the circle is opposite of a straight line. So those opposites are somehow the common asymptote of those circles is somehow modeling that inconsistency, which is supposedly present within the divine mind or within the realm, the divine realm. In another work, he describes the game of a spinning top. If the top spins with infinite velocity, he considers that, then any 2 points on the circumference of the top surface would be co-present with any given point on the fixed circle. And of course, it's impossible to have a real spinning device with spinning with infinite velocity, but this is supposed to show that infinity is not present in our world, cannot be reached from the domain of the finite. Even potential infinity is really impossible, but we can grasp it conceptually. And why? Because it is present somehow in God, and so we can have the idea of it by considering such examples. He considers more examples, but it's enough to understand that the sort of modeling, mathematical modeling he was attempting. He also used a very nice statement or really a model that is much older than his. It was present in the thinking of European theologians at least from the 12th century, and it is represented in this way that let me put it. I don't have it in English. So in English, it's that the infinite sphere. So what is God? Deus. God is the infinite sphere whose center is everywhere and whose circumference is nowhere. It's a beautiful picture, I think. Rather paradoxical, of course. I will later, in a few moments, give an example of something that is a bit similar, but much more precise mathematically. Nicholas of Cusa also tried other ways of describing God using mathematical concepts. So, for example, he said that it's like an infinite angle or infinite number without making it more specific. Or even he claimed that, 1 times 1 equals 1 is a name of God. Why? It's not clear to me, but he did write something like that. And this reminds us of another important person, scholar, namely Leibniz. Leibniz also loved, he tried to do mathematical considerations that would illustrate or illuminate theological matters. And number 1 was also considered by him as in a theological way. Namely, Leibniz, as is well known, invented or developed the binary system of notation, something very familiar to us. So he was really delighted that 0 and 1 suffice to represent every number. And to him, it meant that somehow the biblical description of creation was confirmed, that, zero is like the emptiness, empty void is zero, and the Spirit of God, who is one, was able to create from zero or nothing, was create every number or everything. So we can put it another way, that in every created thing there is 0 and 1, or both nothingness due to us and perfection coming from God. Well, so this is also Leibniz was writing more about things. His famous line is that as God calculates and executes thought, the world comes into being. So we can say that to him, God was a sort of a mathematician. Of course, being critical, we should ask whether Leibniz applies mathematics in his theological considerations, or just, has both mathematical and theological writings that are really not influencing each other. There is an interesting way of explaining the connection that was published later in the 19th century by Émile du Bois-Reymond, who wrote that Leibniz conceives God in the creation of the world like a mathematician who is solving a minimum problem. This is the problem, the idea of our world is the best of all possible worlds, a very well-known concept that Leibniz was developing. And so he says, Raymond, that it's like the question to determine among an infinite number of possible worlds, that world for which the sum of necessary evil is minimal, is a minimum. And this interpretation, really is showing a sort of mathematical interpretation of what Leibniz did. But we can, and it's people, for example, Max Planck liked that interpretation. And it can be generalized because many physical theories can be seen as the application of a sort of principle of a similar kind, of the least action, or something, some sort of parameter has to be minimized or maximized or something. So Leibniz could be seen as a forerunner of this approach, and not only in physics, but even in theology. But we can still ask, how essential is the use of mathematics here? How essential is the use of mathematics on those considerations by Leibniz? Because the mathematical terminology does not seem to add anything essential to the general idea that our world is the best of all possible worlds. This can be expressed in this mathematical way, but mathematics really is not really needed to express the idea. And more can be said. All those considerations by Cusanus or Leibniz or others in the same style, I would say they strike us as being rather naive speculations. Nobody, trying seriously to think about such matters today really is using such illustrations seriously. So, for example, in the monumental volume, Models of God, edited by Diller and Kasher in 2013, where there are dozens and dozens of models of divinity, there are no mathematical models. No, not at all. Also, so it means that also in some other attempts, the mathematical models are not really used. So it means that this is not something that modern day theologians or philosophers of religion consider as very important or hopeful. Still, it is sometimes occasionally invoked by the mathematical concepts or mathematical models. One is to begin with a very simple example, somehow connected to what I have already indicated, mentioning Nicholas of Cusa, namely that some people criticize the Christian concept of Trinity as an absurdity, because it would mean that some, 1 + 1 + 1 = 1, which is of course wrong. But some people would say, and some people have said, that this is maybe wrong, but if you say Aleph 0 + Aleph 0 + Aleph 0 equals Aleph 0, then this is true. So maybe this is a good illustration of the Trinity. Well, maybe, but of course then we can notice that that 4 times Aleph 0 added to itself also gives Aleph 0, so it's as well, would illustrate some other principles. So it shows how really shallow and how not really good are those illustrations, even if they are, just proposed as polemical devices. Maybe a better idea would be to have a Boolean union, because the Boolean union also is, added to itself. It gives itself, so it can work the same way as Aleph 0 or any other Aleph, by the way. But all those speculations seem rather shallow, and really, I don't think any one of us would consider them serious mathematical modeling. Maybe somebody would, so let me leave it to you. Now, in going from numbers or whatever to some more algebraic things to more geometrical considerations, there was a very famous example of presenting some theological matters in the end of the 19th century. The famous book by Abbot of called Flatland. It's a tale about geometric creatures in a flat world. They have only 2 dimensions. So a 3-dimensional being to them, appears suddenly in various places it's a miracle. Whatever, from the flatlander's perspective, the 3-dimensional beings have all those miraculous or divine properties. And this is the main point of the book, which is also very nice to read and very interesting, because it is also a satire on the British society of the time. So that's why this is other dimension is somehow miraculous, and it can then make us understand what Boethius had in mind, in many centuries before, when he was writing that God abides forever in an eternal present, and embracing the whole infinite sweep of the past and of the future, contemplates all that falls within its simple cognition as if it were now taking place. So it's like has, all the infinite realm in one moment, perceived in one moment. So this, I think, is a very interesting illustration of certainly of the other dimension, of a dimension that is goes beyond what we consider the normal space for us. How much it is theological as such is, of course, debatable, because it is, there are those miraculous, that is really unexpected properties, yes. But does it make sense to call them divine or anything like that? We can be rather skeptical. Another much more recent example is well known. I just want only to mention it. It's the modal logic version of the ontological argument. It was presented by Leibniz, and a famous version is due to Gödel. This has been extensively studied and explored, and I am not going to say anything more about that, with one exception, namely, to me, a most illuminating observation on that, in that area, and I know it from Pier Giorgio Odifreddi, is that mathematically we can express this existence, of that object which has all maximal positive properties, which is ex definitione considered God. So mathematically, this can be expressed as the existence of an ultrafilter. And in every finite case, an ultrafilter must be principal, so a special element is determined. Without going into details, we can just observe that, if we look at the existence of an ultrafilter, it's mathematically interesting, but how theological it is, does it have theological significance, is of course rather doubtful. If you have to assume many things and to assume that all the positive property and having all the positive properties, it makes sense and somehow really does explain the concept of God. And this, to me, this doesn't really appeal at all. And the ultrafilter sort of considerations show how, again, irrelevant the argument is. To me, I know that for too many other people, this modal logic version of the ontological argument is highly interesting and somehow relevant. Next is, something that we all know a lot about, but let me mention some subtleties of the issue. Namely, Cantor differentiated between infinity, various infinities, and the so-called absolute infinity. And of course, we now are used to it, and we think it's mathematically correct to make this distinction between so-called sets, also infinite sets on the one hand, and the proper classes on the other hand. The sets are treated as unities, as completed wholes, but those absolutely infinite collections could not be treated as completed unities. This is the main point. Yet, although this has been very strongly, proposed as an important issue by Cantor, and with theological considerations of various kinds, which is rather well known, another well-known development of that theory was that, von Neumann, Bernays, and Gödel formulated axiomatic theories in which sense and proper classes are treated as objects in the same way. Of course, they differ. They have different properties, but still they are objects of the theories. so they can be seen as unities in some ways. Now, there is an interesting, what I want to say is that it seems that the Cantorian construction and Cantorian insight, the insight of Cantor into, and the distinction between those regular say and absolute infinities, has a theological potential that is still somehow present. It's not, of course, a mathematical model, but it is an illustration that has a theological potential. So now we are used a little bit after, for many decades, we have been used to the concept of this cumulative hierarchy of sets, and the sets are somehow seen as being formed in stages and in a transfinite way, and the totality of those transfinite processes gives this something which is absolutely infinite, or a proper class in a mathematical technical language. Now the question is how large that hierarchy is, and we know that there are all sorts of large infinities, large cardinal numbers defined, and it's unclear how big they are. But as also is very well known, the hierarchy of pure sets is constructed entirely from the empty set by combination of taking a set of previously constructed sets in a transfinite process. So this is something that probably Leibniz, had he known modern set theory, would love, because it shows that the all-powerful will that is needed, or we assume is possible, to create from the empty set or nothing, everything, all pure sets, and all in the pure sets we can represent every other set and every other structure. But we need this transfinite, infinite, absolutely infinite time, so to say, and will to construct. And this has a theological really flavor, right? The infinite time process and the infinite and the will to create all sets that are possible to create. But that's not all. It's not the end of it. Namely, the question is, if we collect, and try and do the whole process, how much really can be done? That is, how many sets and structures and infinite cardinalities and huge cardinalities of those special kinds that are being defined by set theorists are possible. So how high and how wide is the cumulative hierarchy of sets? And there is no good answer to it. But if we are really, in the same mood as Cantor was, and he, now is followed by nearly everyone in the mathematical world, we can say that, okay, so let's make the whole cumulative hierarchy of sets, and let's consider this as finished. And now we can construct a super hierarchy over that hierarchy. And there are such theories, or there are attempts to do such theories. But then we can say, make a super hierarchy and super hierarchy, etc. So we can now take another, another transfinite process of making. So, and then we can go on and go on. And the question is when, where, and how can we stop? And in what sense does it make sense to stop? And so this concept, so the metaphorical concept of this absolute infinity can be even strengthened in some sense. I mean, put beyond what Cantor did himself. And, in one author says, his name is Menzel, that, how many of those sets are really exist, as many as God in fact chose to collect. So somehow he thinks that only a theological sort of argument can really be the answer to the question, how big is the hierarchy of sets? But anyway, all those considerations show something that I would present that way, namely that this Cantorian realm of infinite sets has a certain mathematical analogues of transcendence. Whatever transcends the hierarchy that we have, that we consider as good, as acceptable, is something like transcendence in the theological sense. So it's a nice, I think, illustration of the concept of transcendence, mathematical illustration. It's not a model. And although maybe the distinction between models and illustrations is not really very strict, there is probably, a whole possibility to go from illustrations to more developed illustrations to models, but generally it's a metaphorical illustration rather than genuine models. There have been much less important and much less known attempts to do real mathematical models. One is by James Miller, 1998, who tries to show that a mathematical model, explaining why submission to God's will provides more freedom than does disobedience to God's will. And this is something that is not easy to present in the everyday language, because he considers a certain Gaussian, model, Gaussian curve in the space of possible options we have in our behavior, and that in a given moment of one's life. And what he says is that there are some options that are more like, of the animal sort of in the equality, and on the one extreme and the other extreme are the very human hubris, so to say, also, so both animal and human hubris options are bad, but the acceptable options would be those in the middle that are, so basically this is the picture. So the number of options is the y, the y's, and the x axis is from the animal to the hubris, and whatever is in the middle is acceptable, whatever is much to the left or right extreme is not acceptable. So we see that there are more and the options are below the curve. So he says, and we see that, you know, those middle of the way options are more numerous than those that are extreme, either on the left or on the right. And this means that it's that doing the middle of the way is which God wants us to, is somehow gives us more freedom, because there are more options really. So we are more free that way, if than in the case we did you know, something from the extreme part. So it's an interesting illustration, but of course, you know, there are many questions to ask. You know, in what sense, you know, those options are really form a good space, and why the curve is the Gaussian curve, and all those things that we can ask. So it's not really something that is convincing to me, but certainly it's an attempt to give a modern mathematical sort of model of things that are normally considered by theologians. Another example is by John Post, 1974, who tries, in the spirit of Quine's naturalism and minimalism, to express the foundation of theism, avoiding, as he wrote, metaphorical, analogical, symbolic, and mythical talk about God. What he does really is that he defines God or Godhead as the smallest set G, such that its transitive closure, which means, you know, is like the elements of elements, elements of elements of elements, etc., all of them taken together, includes the set of all true sentences about sets, and also the set of true sentences about justice, virtues, religious experience, whatever it may mean for us, etc., etc. And this set G is, of course, mysterious. It combines transcendence and immanence, contains complete knowledge, and the mythic personal God is its intended object. So this is this sort of construction. So again, it is a mathematical construction. Does it really have a theological significance? You know, perhaps it would be too easy to say that, you know, people who really, if they are religious or if they pray, I don't think they pray to the smallest set G such that, etc., etc. And in general, you know, how much it contributes to our understanding of theological matters, I don't think it gives us much, even though it is a mathematical model of something that has at least theological motivation. Okay, now there is something that I just want to mention, but it's not easy to express in a few words, namely theological philosophy of Franz Rosenzweig, presented 100 years ago in a very interesting and rather difficult volume, The Start of Redemption. And he was using, among other things, some mathematical concepts, especially Hermann Cohen's approach to infinitely small, to explain the creation of something from nothing. The idea is that, you know, Cohen, or the famous neo-Kantian philosopher, considered the concepts of the calculus in the style that was that was really there in the 17th and 18th centuries, and was already completely unacceptable to mathematicians in the 19th century, let alone later. Still, you know, he stressed the fact that it is motion that generates finite structures from, or finite curves, say, from infinitesimals. That is from infinitely small or in some way nothings. So by movement from nothing, we create something. And this is used by Rosenzweig in his philosophical, but really theological philosophical system or vision. And again, it is not a model, and this is a mathematical inspiration of approaching mathematics in a way, or using mathematics in a way that was already sort of anachronistic, but it is certainly loosely analogical, an illustration, an allegory rather than a real model. Yet, at the same time, let me say that just now, I mean, in recent years, Ilya Dworkin is trying to use the category theory to give a model to explaining the system of Rosenzweig. Because in the system of Rosenzweig, there is a lot of movement, motion, things, you know, go from one to a shape to another. And the whole world is presented that way. And sets are very rigid and stable and motionless. And the categories probably give a possibility of representing that dynamical sort of reality. And this is something Dworkin has tried to do, but so far as I know, this is more of an idea than a developed and completed model, mathematical model of theological, philosophical system of Rosenzweig. To sum it up, you know, basically all those models mentioned before are either vague metaphors, imprecise suggestions or illustrations, or they use perhaps precise mathematics, but then their relevance is questionable. So either they are too vague and metaphoric, or too, you know, don't seem to relevant enough. Is it possible to have a better situation? Let me present another model which I developed a few years ago, and this is a model of Martin Buber's theology. Now, without again going into details of his philosophy and theology, he wrote again 100 years ago in his famous book I and Thou that the extended lines of relations meet in the eternal Thou. Relations meet interhuman relations between two individual human beings, basically. And somehow the extended lines of relations, they present the eternal Thou, which is his way of representing God or presenting God or the divine realm. To everybody who is somehow educated mathematically properly, it probably should strike that this idea is somehow similar to the idea of the projective plane, in which we have points at infinity. Every line, the direction of a line is a point in infinity. All parallel lines have the same point in infinity as their direction, and on both sides is the same point. And so the totality of those points at infinity constitutes one straight line in infinity or at infinity. And I would say that it does correspond to God in Buber's vision. It's important that the same infinite, the same on both ends, the same point at infinity is reached, and also that one point does not determine a line, only 2 points determine a straight line. So it's like in Buber's system that you need a relation between two people to get to that eternal, though. So anyway, you know, without going into details, it seems to be a fine illustration of that system, and the line in infinity becomes the area of transcendence, a good mathematical model of the transcendent. And even more can be said, namely, we can have the well-known model of the projective plane in the three-dimensional Euclidean geometry, and it is presented by a hemisphere. So we have all the points of the northern hemisphere presented here as the finite proper points, and the points at infinity are those on the equator, but they are identified if they are on the opposite sides. So the two green ones are identified, they are really 1 point. Two red ones are also 1 point, etc. And or we can think that, you know, the point at infinity is the whole segment from the green to the green, together with its ends, if you want so. And in some sense, you can see that the line at infinity, the points at infinity form this line, and or this foundation of the northern hemisphere, and this is like a good illustration of the foundation of the world. Yes. So it is a good model of transcendence, I think. In addition, it can also be used, this model, as a tool, let me say that, as a tool assisting meditation during the Jewish prayer involving among the Shema, or Hear Israel, Hashem, or God Hashem is one. Hashem is the indication of the name of God. Well, I won't perhaps explain that in details, but the point is that we can imagine that the whole line at infinity, or the whole equator with the opposite points identified, shrinks or becomes 1 point. So we go beyond projective geometry. The line at infinity representing transcendence becomes 1 point, or the equator shrinks to 1 point. And this is this is like the final point of that meditation, or that pictorial presentation of that sort of meditation. And this is something that I think is quite useful, can be quite useful. And it goes beyond projective geometry, because we say that God is one, which means that the whole transcendent area becomes 1 point only. Anyway, this is hard to imagine, which is good, because this makes us realize that transcendence is hard to imagine, or is paradoxical. So to create such a model is not impossible, it's maybe not difficult, but of course we can and we should ask how useful is this model, and are such models and possible models in general of theological or religious matters in general. So the question of usefulness of this particular model that I've just presented, so we can question the value of that model in two ways. One is that, you know, it really illustrates matters that have nothing to do with mathematics. And perhaps they are similarly naive as the, you know, what Nicholas of Cusa or Leibniz was writing when, you know, maybe this is a bit more sophisticated mathematics, but it's perhaps only now it's more sophisticated, and in some time perhaps it will be seen as simple as the, you know, those circles tangent in one point of Cusanus seem to us. It's a very simple model that doesn't really give anything very important to theological considerations, and maybe this will be seen the same way in some future. But I think at the moment that model is not trivial. The projective plane model of Buber's system. And the other criticism would be, does this model enable us to achieve a significant progress in our quest to understand theology? And in addition, does it make possible an unexpected conclusion in the field of theology? This is the main thing that I'm coming to, and I mentioned at the very beginning. You know, I don't have a positive answer to the questions, to those two last questions, unfortunately. So my guess is that no, it really does not help to have a significant progress in our understanding of theological matters. It is a nice illustration, but you know, it's as with all metaphors or all models, it's all, you know, there are some aspects of the mathematical model that are really illuminating, and they fit the theological ideas, but there are other features of the mathematical structure or the mathematical model that probably have no theological counterpart. Like, for example, the fact that the projective plane is non-orientable. It's an interesting thing, you know. Can it have maybe somebody can imagine some sort of theological interpretation of that, but it's clear that if we want to go too far in that direction, that would become very soon questionable. More generally speaking, you know, it's either we think that the geometrical model or the mathematical model in general is an adequate description of the theological idea, but then theology look rather meager, rather, you know, weak compared to mathematics. On the other hand, we can think that it's theology or philosophy that deal with really important matters of humankind and of the world. And mathematical illustrations are no more than illustrations that are really maybe suggestive, but fundamentally irrelevant. It's very hard to have an example of a situation in which both sides, the theological or maybe philosophical theological and the other mathematical, are strong deep and illuminate and illuminate each other, or can be considered as important enough. Now, let me say that it still can be very useful, because I think that theologians and philosophers, and also everybody really, very often have some sort of metaphorical models in mind when they talk about abstract matters or about other matters that are not very concrete, very easy to point down, And so such mathematical models can be helpful if you try to recover what a given theologian wanted to express, to say, to tell us. And in this sense, the mathematical models can be helpful. But they be helpful not in this sense, but in a more in a deeper sense, like they are in science. In science, mathematical models are only models. That is, they reflect only some part of reality, of the real physical or other reality. But they do it they present essential aspects, or at least we believe so. And this is even more important, they can be creative. That is, they can reveal unexpected properties of the modeled world. For example, all properties, I quote Michael Heller, all properties of quarks have been deduced from mathematical models, in which, nota bene, quarks had been initially absent. Here, mathematics was very creative in physics. The question is whether in non-scientific uses of mathematical models, we can have similar creativeness. Well, this is a very interesting and much more general question. It's not only about theology. I think it's more about the humane societies, sciences in general. Maybe the catastrophe theory, as developed by René Thom, was one attempt to show how in history, in some social situations, mathematical models can explain behavior. So who knows? There are other attempts, but if the mathematical model is supposed to be more than a metaphor, or more than a suggestive picture or visualization, then we have to be given an example in which a new property or some unexpected property of theological character would be revealed by the model. But the question is, does it even make sense to expect that? I'm not sure. It seems not really a good idea to expect, this sort of predictive power from mathematical models of theological matters. So it seems that there is a difference between scientific models and not only theological, but also other humanistic sort of models. Of course, which are rather illustrations than models in the strict sense of the term, that we can create a new understanding. There is maybe one exception to that, namely statistical analysis. And in fact, in sociology and perhaps even in theology, we can, have the statistical analysis of texts or of objects, and then various religious or conclusions about religious matters can be made on the basis of statistics. But that's something else. This is about texts or objects, not about theological divine matters as such. So it's more the use of sociological, I would say, use of statistical methods rather than directly theological use of it. So to conclude, it's rather illustrations than models in the strict sense, certainly in theology. But maybe, this is all due to the fact that our mathematics, current mathematics, is not really good for theological and maybe also other humanistic uses, because it has been developed more to assist or to be a tool of science, of natural sciences. And maybe another mathematics is needed, it was mentioned 25 years ago by Keith Devlin in his book Goodbye Descartes, in which he says that perhaps another sort of mathematics, a soft mathematics, is needed, and that novel mathematics would avoid reductionism, because so far mathematics achieves its incomparable precision by reducing life situations to rigid abstract structures. And some theologians try to do that. I don't think it's a good way of doing things in theology. But that's my opinion. Of course, others have another opinion about that. But if this sort of soft mathematics emerges, perhaps it will be also applicable to theology. That's it. Thank you.
Okay, very much. Thank you very much for your nice talk. If you have any question, please raise your hand so that we can go to our Q&A session. So, okay.
Can I have a question?
Megan Page, could you please, Megan? Huh?
Yeah, hi. Thank you. I really enjoyed your talk, and I share a lot of your sympathies. I wanted to ask a question about at the end when you were talking about, could theological models be creative? And I think that is like the big important question, and how they often seem to differ from scientific models. But for me, the worry often isn't like, could they be creative? It's how would we know, how would we verify that the new suggestions they make are correct? So, I mean, for example, like with the Aleph-Not model or something, and it's like, well, adding it together 3 times, you still get itself. But it's also true that adding it together 4 times, you get itself. And what if we said like, oh, well, we learned something, God is really 4? Or do you know what I mean? Or like God could be, so it's hard because we could always say like, this is giving us new theological knowledge. But if we get a challenging theological assumption, I feel like the question is verification, because in the scientific case, we have ways to test it empirically to go back and check if the new creative suggestions are right. And I feel like sometimes the worry in the theological model isn't that it doesn't offer new suggestions. It might. I mean, in a lot of the cases you talked about, you could take what you were saying, like the things that you said, well, it's not a good model because it says these other things. You could just say, no, it turns out those things are surprising truths, right? But we don't, like, the question is verification. So I'm just wondering what your thoughts are about that.
Well, thank you. I agree with you, of course. But verification would mean in this case that something that is, suggested by the model is also accepted on other grounds by some theologians, or was accepted and then, you know, it somehow looks that the model is providing a good illustration of something, and something unexpected comes. And I think that's if something unexpected is provided by the model, it's already would be something, you know, unexpected and not really, you know, there from the very beginning, something like this. But verification of theology is a matter of what other theologians say, you know, and this is of course the question of a tradition. It must be a tradition of theology that is, you know, because it's not a scientific sort of confirmation, obviously.
Okay, will I chat? Will I go forward?
Thank you. Thank you so much. Stanisław, thank you very much for a very nice and instructive presentation. As usual, you give a lot of things to think over. If I got it right, I quite agree with you that we often looking at the classical and perhaps even contemporary examples of mathematical models in theology. We can easily discard them as naive, as too simple, as not giving us the whole picture, all answers. But perhaps the central problem is here the fundamental difference between the divine reality and the natural phenomena. If we want some mathematical model for some natural phenomena, what is our aim? We want to have some instrument to handle these phenomena as we want. Is it a good approach towards divine phenomena? I'm not quite sure that it is. In this case, perhaps we just need something incomplete. We just need some hint. We just need some inspiration, nothing more. And this approach towards the way mathematics can be used and should be used in theology and in religious life is a very classical one. For example, in the late antiquity, Neoplatonism, we see exactly this approach. For example, when Plotinus discusses such things or similar things, he gives us some comparison. If we want, before we get some theophany, before we get in a way into a sanctuary and meet face to face with divine reality, we came through something that stands between profane life and the sanctuary. And this is, in the case of Plotinus, is some kind of sculptures or some art that shows us or hints at the divine reality. And this is enough for us. It gives us some hints we need. It's something that we need on this, something that stands in this intermediate place. It doesn't need to be something complete. And perhaps these, so to say, faults or incompletenesses of theological, mathematical models in theology are not their weakness, but their strength. For they give us exactly what we need. Nothing more, but nothing less as well. What do you think about it? Thank you.
Well, thank you. There is nothing much I can say about this. Certainly, it's incompleteness is, but it also appears, I think, in the description of physical realities. Our descriptions of physical or real life situations are also incomplete, always incomplete. So modeling is necessarily very much incomplete. In this sense, I don't see much difference, but the creative element of it is there, and it seems to be not present in, as I said. So there's nothing much I can add. But of course, the idea that what we need is suggestions, you know, inspiration, etc. Yes, and of course, so as I said, you know, to understand what people who are writing about theology had in mind, and here models can help.
Okay, Bruce Caproy.
Yes, Professor Krajewski, yeah, thank you very much for the talk. Very enjoyable. I want to think about maybe most of the examples that you gave were about perhaps limitations when it comes to things like ontological argument, proving existence, or discussing positive aspects of God. I'm wondering about the utility of mathematical models in maybe discussing negatives or hypotheticals. And I have two examples in mind. The first one is Gersonides in Wars of the Lord, his discussion of God's knowledge of particulars, where the question is whether or not God can know all the divisions of a continuous quantity. And because Gersonides has a Aristotelian notion of potential infinity, he makes an argument against Averroes. Averroes is saying that God can know all the divisions of a continuous quantity. And Gersonides makes an argument that this just contradicts the notion of potential infinity in some sense. So that, you know, what God can know is that God can know that given any division, another division is possible, but God couldn't possibly know anything more than that, because anything more than that would be contradiction. So I'm thinking, you know, maybe while you can't argue God is this or God is that, you can make arguments that God can't do this or can't do that.
I think, you know, that those who are against Cantor's theory of infinite sets, which has completely dominated modern mathematics, they maybe thought that way, you know, something like that, you know, there are potential infinite processes, but all those actual infinities cannot be there all together because it would be inconsistent or something. That this is what just came to my mind. So maybe the negative also, but now we are much more used to the whole realm of infinities.
Oh, sure.
And it doesn't seem inconsistent to us. At least that's what we are thinking, what we've been, you know, used to. So, but maybe I don't really get the point, you know.
Oh, the point is that
the negative
that it is it's a theological. It uses mathematics and a theological. I mean, it's really an argument about mathematics more than about theology, but you know, it's in the context of this theological argument about God's knowledge of particulars.
So, for example, is mathematics somehow I mean, there are the limitations to mathematics. I think that modern mathematics is still probably not using it's not illustrating or describing the dynamic vision of the world sufficiently, because all those mathematical objects are rather stable. Of course, we can describe a motion, but we describe the motion using, you know, the concept of a space and a curve and a function, and all those are usually seen as completed, stable objects, which taken together properly describe motion. But the dynamic aspect of reality probably is not expressed in mathematics properly, and maybe there are some theological approaches that can somehow take advantage of this, but I don't know anything specific about it.
May I just mention one other example, which is more in a more modern context. So Rudy Rucker, in his book Infinity in the Mind, argues that the reflection principle in set theory, which says that any property of the class of all sets must actually be true of some lower level of the cumulative hierarchy, is an argument in favor of kind of negative theology, that if you identified Godhead with absolute infinity, then you can't assert any positive property of the Godhead, because it would just be a property of some, less perfect being. So it's a hypothetical. It doesn't say God is this, but if we accept that God is, or if we identify God with absolute infinity, then we must reach this conclusion.
Yeah, you're right. That's a very nice illustration of transcendence again, or of the how yes, but again, here the problem is what is a property, because the reflection principle is, yes, it has been used in many ways, but for specific properties. If we say that it's true for any possible property, then we need to know what properties are, and this is not something that is clear enough.
Sure, yeah.
And that's why it's a general approach to the issue, but it's an interesting problem, what is the extent of this reflection principle. But it's another very good example, thank you for it, of this theological flavor of Kantorian set universe.
Well, regarding Bruce's comment on large cardinals and reflection principle. So even on that type of interpretation, there is a hard limit above everything, namely the Cusanus inconsistency. So you cannot have a reflection principle of arbitrary strong nature, so that you will reach a kind of inconsistency, presumably with axiom of. Even in that case, it seems there is a hard limit about every reflection principle. So, Terry Rankin. Terry?
Can't hear you.
Right. It takes me a minute to unmute. I apologize. First, let me thank you very much for this session. It's been illuminating and inspiring, frankly. The approach I took, I confronted the problem. I came to, for lack of a better word, I'll say religious faith, rather late in life, about midlife. And suddenly, having studied philosophy of science and mathematics for quite a while up till then, I faced a conundrum. How do I bring those two modes of knowing together, right? The religion and the scientific or the analytic. Gilchrist would call the left and right brain. How do you bring those two hemispheres into a kind of resonant harmony? So I undertook a philosophical, quasi-theological inquiry through a Doctor of Ministry program, which I just completed 3 years ago. Late in life, but never too late, as they say. So to sum it up, I had to deal with this very problem. What kind of cosmology, which is what I wanted to construct, would allow me to bring that faith-based theological perspective and that analytic-based scientific perspective into some kind of, I won't say reconciliation or unification. I prefer the musical analogy of resonant harmony and synchrony. Because in resonant harmony and synchrony, you get all the differences as well as what you might call the greatest common factors. So anyway, in going down that path, what I settled into, and let me preface this by saying, the first thing I had to settle into was no matter what I come up with in this model, in this metaphor, it's going to be A, incomplete, and B, probably not complete, not sound in the logical sense, right? If everything derivable is entailed and everything entailed is derivable, I didn't figure that that was going to be achieved, and that it would contain a certain element of mystery. So I knew or believed going in that that would have to be the case. So I started with Charles Sanders Peirce's semiotics as the grounding of what I was going to try to do. In Europe, you probably know more about Ferdinand de Saussure, the other semiotician of the era. From there, I had to deal with the issue of set theory in that classic Cantorian, Patrick Suppy's axiomatic way of looking at it. And for me, there seemed, as a believer, as one looking through the faith lens, there seemed to be something missing. Again, that musical metaphor of the resonant harmony of differences that you get when you're in a particular key in music, or even the dissonance when you play off key that is often used for contrast in a performance of a symphony. So I like that musical metaphor. It goes all the way back to Pythagoras, and it certainly sits well with modern contemporary string theory, resonant harmonies and synchrony, right? So sorry, my battery's running low. I have to plug in here right quick.
Thank you.
So with all of that in mind, I've settled on the notion in Christianity of the mandorla, not mandala, which you see in Eastern religions, but in Christian theology, going back to even the first church days. And I believe also in Old Testament theology, there's this notion of resonant harmony of differences. And the image is the two-figure Venn diagram. But the intersection isn't just the things they have in common. It's all the things that resonate harmoniously and synchronously between the two sets. And that's kind of a unique way to look at the dynamics, I think, of set theory. So anyway, I picked on that mandorla as kind of a fundamental of the set theoretic perspective I took. So now I'm dealing with, okay, so what's the whole mathematics I need to look at? And I ended up going to the Mandelbrot set because it gives a very lucid presentation algebraically and geometrically of recursion and iteration. And it seemed to me that in classic set theory, and even in these dialogues and presentation I heard today, the idea of recursively or iteratively moving through the dynamics of set theory relationships, that recursion and iteration is the relation at work. And that really comes into fruition when you get into the complex number system with the imaginary numbers and you apply the Mandelbrot recursion and iteration. So long story short, I did build a model or sketched. I'm no mathematician. I can't work through all the elaborate mathematics of this. I'm not that. No, I hope I don't offend anyone by saying this, but I'm not obsessive and compulsive enough to work through all of that symbolism. Okay, I'm kind of an amateur or hobby mathematician, but just dealing with it intuitively and conceptually, those three characteristics, Peirce's semiotics, the Christian mandorla for set theory dynamics of resonant harmony and synchrony, and finally the mathematics of complex algebraic or geometric analytics, like Mandelbrot discovered and presented to the world. That's where I built my metaphor. It stands on its own as a scientific model, I think, mathematically, and it has a point of connection, just like one universe touching another. Neither universe is the other, but they touch at a certain point, let's say, if you go for a multiverse model. But
I'm sorry for interrupting you, but I think you're giving another lecture, which is perhaps...
Okay, I'll stop right there then. Yeah. I was just wanted to thank you for helping me rethink my own model and get a clearer perspective on it. Thank you.
Thanks.
Hey, Henrik. Henrik, go.
Can I make a question? Hello?
Arundhati, please wait until
yes.
Guys. Yes, please.
Okay.
I will come back to you. Henrik, can you hear me? Henrik Boom?
Oh, you mean Hendrik? Okay.
Uh-huh.
Yes. Can you hear me?
Yes.
Good. I have not a question, but more a comment, a piece of physics that may be relevant to some things. You commented on the difficulty of sort of creating something from nothing. Just want to comment that Richard Feynman once estimated the total mass energy of the universe, considering that gravitational potential energy is negative. When we added it all up, he said the sum is suspiciously close to zero. So maybe it's not a violation of physics to create something out of nothing. That's all.
Thank you.
Okay, next question, Alexei.
Thank you for your very enjoyable talk. Especially I liked a flavor of skepticism of your talk. And perhaps many will agree that the pace at which mathematics is developing is rather higher than that of theology development. Does it point at a fundamental difference between mathematics and theology, contrary to what Nicholas of Cusa suggested? How would you comment on this?
Well, they certainly differ in many ways, but they are also similar. You know, there are many similarities between mathematics and theology, like, you know, an abstract.
But theology is behind in at least at the terms of its pace of development.
I agree with you, but maybe, yeah.
Mathematics provides a lot of tools for modeling, and theology kind of very reluctant to use them. Does it point at some fundamental difference?
I don't know. I don't know. It's a good question. But I think that some theological concepts are used in mathematics. Like, I mean, very general theological inspirations, like, you know, infinity and all that, you know, that we can go make transfinite processes. It's a theological concept, and it was expressed like that in when the modern set theory was being born.
Could mathematics be a different theology? Not traditional view or understanding of God?
Are you suggesting that we can have another theology due to mathematics?
Yeah, mathematics is a different view at God, like Einstein's religious views were very much religious, but not in traditional sense.
I don't believe that religions or theologies could develop outside the traditions. Of course, the traditions can evaluate, and can expand, and can incorporate more insights, but I don't believe that it.
What about Buber's theology? Buber's theology is it traditional?
It's based on tradition. Of course, it's there is something new there, but without
his direction is very much different.
Yeah, I agree. But you know, even if we talk about theology, we talk about God. But if you want to understand what God means, the term God means, we need to refer to a tradition, because without a tradition, that word becomes that very term becomes completely ununderstandable. And so even such, you know, attempts as Buber's, which go very far from the tradition in some ways, they do refer to the same tradition, because otherwise we wouldn't be able to understand the terms, because the terms the words we use are understood either because of our everyday experience or because of some traditions. And those traditions in theology are everything. I mean, there's nothing theologically important when we just completely ignore the tradition. That's what my view, at least.
Another question. In your model of Buber's theology, you insisted that the projective geometry line is not good, that let's better have a point. Why line can be God? Why you insist that God is a point? Why not a line or any other thing?
No.
Mathematical
we
concept.
Can model whatever we want. We can model God or transcendence by a line at infinity. Of course, there is no problem with that. What I wanted to say is that if we visualize the line at infinity becoming a point, this is useful for as a tool for visualization or meditation for a certain prayer.
Okay.
That was my point.
Oh,
Not that we have to, but we may do it, and this can be helpful in some sense.
Okay. Thank you.
Thank you.
Well, let me add a few remarks regarding Alex's question. Alexei, there are mathematicians, in particular set theorists, who refer to theological concepts in the middle of the. So, for example, Cohen, while inventing forcing method in set theory, actually spoke about the language of set theory being similar to the language of theology, where you can you have no access to the actual objects, actual spiritual objects, like devil, like spirits, like God, but you have names for them in your model, so you can manipulate the names and construct a language, which is the language of theology, inside the model, and conclude some facts about the spiritual or the higher model or the forcing extension. There are such comments like that. Also, Cantor very famously spoke about the absolute infinity. Also, Gödel seems inspired by some theological concepts. For example, what is Gödel numbering? Isn't it similar to where you assign a number to any letter of the language and then do some calculations inside arithmetic and then translate it back to some facts about the universe, which is actually the Gödel sentence. So the same spirit seems to be appearing here and there.
Gödel's numbers is just a trick.
I know, but it seems to be inspired from actually familiarity with the actually Kabbalah and the method of coding language and then manipulating numbers and concluding something about the language. So, Arundhati, it seems you had a question.
Yes. Yeah. So can I? Okay. So I enjoyed your talk very much. So just I have one question. Actually, at one point of time in your talk, you just told that you made a distinction between metaphorical and a genuine one. But here I actually have some kind of I want to say something here. But don't you think that everything fundamentally is metaphorical? We are always taking things as a carrying over, which describes the blending of the features of the one concept to another in a unique combination that results in a new shade of meaning. Don't you think this? That everything is actually basically metaphorical.
I agree with you.
So,
I think you are absolutely right. Yes. And yeah, but mathematical models are special sorts of metaphor which are more developed more, I don't know, they have some structure which is rigid and very rich sometimes. But I agree that metaphor, that's why I began with metaphors as something are absolutely indispensable.
No, but actually I was confused when you made the distinction between metaphorical and the genuine one. So I think there is no distinction actually between these two.
No, so, I meant that metaphoric, loosely metaphoric on the one hand, and strictly mathematical model, which is also a metaphor, but it's more of another kind. You know, there's a difference between loose illustrations and strict mathematical structure, although as a model, although they both are metaphors in generally speaking, yes.
Do you know the book by Yuri Manin, Mathematics as Metaphor?
Yes, I do.
Yuri Manin.
Yes. Mm-hmm. Yeah. Yes, yeah, there, yeah, I do. Yes.
Philosophy. Okay, thank you very much. Thank you.
Yeah. So you are adopting a fictionalist view of mathematics in your approach, right?
Not necessarily.
I mean, you are describing mathematical models as metaphors. So not all mathematicians actually do that, because, for example, Platonists actually don't agree the mathematical model is just a model or a fiction. They are talking about actual objects, assume that they are talking about actual words. So you are actually talking about kind of fictionalist view of mathematics, right?
No, because what I meant, I didn't mean mathematical. What are mathematical objects? I didn't, comment on that. I meant mathematical models of non-mathematical matters, of something which is non-mathematical. So when we model, I don't know, society, we can model society as a graph. Okay, so this is a good mathematical model, but of course society is much more complex than a graph, you know.
Any other question? So if there is none, I have one question, if possible. Any question?
Now, I have a question remark.
Ken, please go forward.
Yeah, another place where we've seen mathematical modeling is in anthropology and sociology. André Weil and Philippe Courrèges were very beautiful papers on kinship systems and group theory. But I wouldn't call that creative. They didn't, another example is the Yorkshire bell ringers, who actually discovered beautiful algorithms for generating all the permutations of 8, 10, 12 bells using subgroups, using quite elegant, but and that work was only sort of, that predicted what the mathematicians did 100 years later. But so that the creativity went in a sense from the social world into the mathematical world.
I see. Thanks.
Very interesting. Any question? Well, I have one question about the concept of in Kabbalah and the concept of Ein Sof, which is infinity, is referred to God before creation of any spiritual realm. So my question specifically is about the potential problems mathematical discoveries in the field of set theory and infinities can cause for the traditional theological view of God as infinity in Judaism. For instance, Cantor's discovery that there are more than one infinity, or for Cohen's construction of four, actually somehow suggests that any infinity is somehow relative the largeness of an infinity number is relative to the model, and so there is no kind of absolute concept of infinity. So my question is about how the Judaic tradition actually solve these issues and reconcile the traditional views with the math discoveries, especially in the Hasidic tradition, which is a somehow tradition. Does it lead to any new discoveries in the mystical traditional, and specifically in the Hasidic tradition?
Of course, it's a good question. I don't have a good answer, because even the Kabbalists didn't really work in anything that is close to our mathematical concepts. Of course, they had some ideas like permutations in many centuries ago. They considered permutations, or maybe even the space of permutations, some people say, and some philosophers were using those. So in this sense, you can see some connections, but how much it can help us in discovering, I don't know, the roots or the sources of mathematical concepts, an interesting question. But I don't think it's the modeling, mathematical modeling of those Kabbalistic or other considerations is helpful to understand what sort of religious ideas they had, although I don't know, maybe I simply don't know enough about that. But that's basically what comes to my mind. Thanks. So I think it's been almost 2 hours. It's enough, I hope.
Hi, everyone. I guess Ali, for some reason, he lost connection, perhaps.
Yeah,
okay, so meanwhile, is there anyone still has any questions? Oh, so Ali's back.
Sorry, I lost my question, so I lost the answer. So I should find it in the recording.
I didn't have any good answer anyway, so I think it's time to finish.
Very nice. Assis, the floor is yours. Please, the decision.
Yeah. So thank you. I think it's
thank you
long enough. It's been long enough.
Thank you again, Stan and Ali, and everyone who attended the session today. We had incredible exchange with Professor Stan and the other participants. I just want to remind you of our next session that will take place in 1 month, September 15. I'm going to have Professor Kenneth Valpe from Oxford University. He's a well-known scholar in Indian theology. So he'll be talking about scriptural readings of ultimate truth and language in an Indian tradition. So you are all invited to attend again and to participate. Thank you very much. See you all next month. Bye-bye.
Bye-bye. Thanks.
Thank you.
Goodbye. Have a good time.